Yeah, hello everyone. This is Deepak. I'm presenting my presentation on butterfly and moth species detection and classification using deep learning. This is for my thesis, and here I will be giving you an overview using my PPT slides. So in the first slides, we see here I'm using a CRISP-TM model to complete my project. Under CRISP-TM model, as you can see, first step is butterfly understanding, then I'm doing data understanding, then data preparation. After data preparation, I'm doing the modeling part where I'm using 4 different models, and then the evaluation using the precision accuracy of the models, and then the deployment using the Streamlit web application. And under business understanding, you can say the ecosystem monitoring as a service. We can have offering ecosystem monitoring as a service means like we are giving business and organization to real-time insights into the health and diversity so that there is impact on the climate change that can be stopped and everything. And then we can give analytics and decision making. Analytics for decision making and the research and development opportunities for the business so that they can do R&D in such a way that it helps them growing the company with less impact on the climate. Then we can engage stakeholders for the environmental conservations, and then we are brand alignment with the conservations so that reducing less CO2 and carbon free by 2030 and 2050 that you see. So this project will help in that. And coming to data understanding part, the size of the data set that I'm using is consisting of 12,000 images for your training data. And here you can say we have 100 classes. All images are in 224 into 224 pixels and in JPG format. The data is rendered from Kaggle. It is a collection of butterflies and moth species, 100 species. For testing, we have 500 pictures, and for validation also we have the 500 pictures over here. And data preparation step, I have manually downloaded the data from the Kaggle, then loaded it to the Git repository so that we have less dependency on the Kaggle. Then uh, the mm, accessing the data from Python using the code, and then removing that if we have any dodgy images during this process. And you can see this is a sample images for the data sets. And like this we are cleaning the data also. And coming to the modeling part, in modeling part I'm creating a new CNN model named ButterflyNet. So in this custom CNN model, as you can see in the figure here, I have given multiple convolution layers so that I can extract butterfly features because their images are like they have more complex, more colorful in the nature, and it's hard to just go for any specific species and do the identification and classification part. So I am trying to do this using creating a new CNN because earlier it was during earlier research it was like 4 or 5 species detection was there. I am trying to do 100 species detection using this. And another model that I am using is efficient B0 model where this is a already pre-trained model with a large image data. So I'm checking this for the efficiency and so that I can compare the butterfly net at the last. So the same way I'm using some different new researched pre-trained architectures like VGG19 and ResNet 50. This is the architecture of VGG19, which is a very complex architecture, and VGG19 over here and ResNet 50 over here. So it's we have a very pre-trained model with large amount of data. So I'm doing some fine tunings on this one and the ResNet 50 so that it can be used for the 100 species for this project. And then coming to the evaluation part after the project is after we have done the modeling and fine tuning for all the models, and we can see the summary of all the models over here. If we go for the summary of ButterflyNet, we can see the accuracy is 85.40, precision 87%, recall is 85%. which is a little less from all other spas, but still, like this is a new CNN model. It needs more future works, but we have tried to. I have tried to make it more accurate as much possible during my course. And here we see the efficient B naught model, which is a pre-trained model giving the accuracy of 93.60, precision of 94.86, and recall of 93.60. And same when we go to the Resonant 50, I have seen that Resonant 50 is performed very well in this scenario with an accuracy of 95% and precision of 95.66% and recall of 95%. It is higher among all the four models that I have used. And coming to VGG19 model here, the accuracy I got is 92.80 and precision was 93.73. It's not that much far, but still everyone is around like 92 to 90. 5%. And going with the ButterflyNet as being a new model, it is trained on a very less image. Still, we are getting an 85.40 image accuracy, so still is very good over here. And coming to the next part, we can see over here is like deployment. We can see over here is deployment. In deployment, I'm training the model. First step is training the model, and then model is saved in a keyless file. Then a Streamlit web page is created so that an end user can use it in a very interactive way. And it can be more like connectivity between the user and our models. So it can be used by the business also. So here we have options how user can do it. So first, user need to upload an image. The image is uploaded, and prediction is done on the basis of selected models. So there is a snapshot over here. We can select all any models that we want to run on our image, and then we upload an image and we get a prediction like this. And we upload an image and we have an exit button also for the user so that it can go out to the first page as whenever he wants. And so this is how the deployment is working here. And that's all. Thank you. And another video we will be discussing our I will be discussing my code. Thank you for